Hi, I'm Eric Sabo, and today we're going to be touring the Alerton Direct Digital Control System that controls all the heating and cooling in the house. It's unusual to have a system in the house like this, as they're mostly in big buildings like the Empire State Building. I worked there one day. I told them they could have it. Merritt Avenue in Norwalk, 353 Merritt Avenue. I was there all the time. All the buildings along 95 in Stamford and all the newer schools and office buildings have these kind of systems. I subcontracted for Jerry Chesley at Automated Building Systems for 20 years as an installer, and in the last 10 years of my career I was at Unilever World Data Center at 55 Merritt Boulevard in Trumbull, Connecticut. I was installer and programmer there. The system was huge and they really needed somebody full-time for that building alone. And it just so happened I had done a lot of the installation and worked my way in and wound up subcontracting directly for Unilever and Al Hennessy. With these type of control systems, if it's not Alerton, it's usually Honeywell or Johnson Controls. They're the big two. There's a few others like KMC or Automated Logic that are out there, and they try to get their share of the work. I think KMC is most similar to Alerton. New England Energy Controls right here in East Haddam is a KMC rep. And I went down to talk to them a bit, and they were really unhappy they didn't get the contract for the new schools in the town here. Really hated just seeing those Johnson Controls trucks drive by. Johnson really, I don't know, word out is they have to be the worst. Unfortunately, the customer, unless they're really on top of it, doesn't get to choose, because the control company works for the mechanical contractor under Division 15 of the spec, and unless they specify what controls they want in advance, they generally get what they get, and it's usually not a good thing. It would have been in the town's best interest to have KMC, just because they're right here, they don't have to travel. You call Johnson, it may take forever to get them in. That's just the way it is. When I mentioned Jerry Chesley to the New England Energy guys, they really raised eyebrows. Because Jerry's really the leading sales rep for the entire country for Alerton. He's one of the really big distributors, and he's really got New England, southern New England locked up. And I worked for Jerry right from the beginning. We did a million large construction jobs, and as well as retrofits, replacing old pneumatic systems in school systems like Groton and Newtown. Jerry was a perfectionist like me. The devil's in the details. Thing is, I always did all the work myself. No employees. I always said employees are like having kids. They never show up when you absolutely need them. And you can't get guys off the street to do this kind of work. In fact, the electricians generally don't understand this stuff very much at all either. If I hired somebody, I had to stand right behind them and tell them what to do, and I might as well do it myself. It's just easier to do it myself. That way there I knew every aspect of the system installation, and that it was perfect, and when we hit the start button, boom, there were no surprises. Unfortunately, my back is shot and I need 2 shoulder replacements for carrying all them ladders, tools, and equipment in and out of buildings for like 20 years. And then at Unilever, fortunately, that was like working in a hardware store with Al Hennessy. That guy was the best mechanic on earth. He had everything. Best thing I liked about working with Jerry, though, was I could work at my own pace, and whenever I wanted, get there early, get out early, and do whatever I had to do on the way home. The Alerton system here has several components. You have the desktop computer right here that interfaces with the motherboard, which in my system is a microview. But the motherboard is usually an Apex, and an Apex has 4 communication trunk lines that can communicate with 64 terminal unit controllers. We call them tuxes for short. So a standard Apex is 4 channels, 64 per channel, 256 per Apex. At Unilever there was over 350 controllers, so we had to have 2 Apexes. My system has a microview. It's 1 channel with 64 tuxes that can handle that 1 channel. I only have 3 tuxes on my system. 1 for the jacuzzi, 1 for the boiler and wood furnace, and 1 for the family room and air conditioning. I originally installed the system for the jacuzzi, but the thing is, I could actually use this system to test and program sequences for Unilever. So the house was like a test rig. I could test everything out here and then go down there and just load it into the system and know that it absolutely was going to work. I added the family room and assumed boiler and domestic hot water control as time went on here. So the desktop interfaces with the microview motherboard. The microview holds the vast majority of the DDC programming, which we'll look at later. The 3 tuxes on my system are 2 653s and a 16160. The 653 has 6 inputs, and they can be analog, which is a 3000 ohm thermistor for temperature or humidity, or a digital on and off, which would be a switch on and off input. It has 5 digital outputs, which are just 5 on and off relays, and then it has 3 analog outputs, which I don't use any of those here. Those are used for driving valves partially open and closed at 0 to 10 volts DC or 4 to 20 milliamps, however you want to set them up. Honeywell, they use a 10,000 ohm thermistor instead of 3,000 ohm. It's one of the differences. And you can't use Honeywell controllers on the Alerton system. That's a problem. The 653s are fully programmable, so they can stand alone in case they lose communication with the microview. Problem only arises when you have like outdoor air temperature, which is a global point, and all the tuxes use outside air temp. It's only input into one of the tuxes is shot up to the microview, and then the microview shoots it to the other tuxes. Now, what happens when the communication is lost with the microview? The programmable 653 will retain the last input of the outside air temp, say. The 16160 I have in the system is just 16 ins and 16 outs, so it relies totally on the microview DDC programming in it to operate. Takes the inputs up to the microview and it sends the DO commands down to the 16160. Now, these controllers are not cheap. They're like $1,200 to $1,600 per controller. The microview is $2,200, and Apexes, well, they used to be $3,500, then they went to $7,000, and now they're up to $20,000 because Honeywell bought Alerton. They're trying to phase all of this equipment out. And so if you have a pile of Apexes in your closet, it's a good thing. You're rich. The problem is when you have a system like this in your building, like Unilever has over 350 controllers, you're not going to change that system out real fast. The rest of the Unilever campus has over 900 Honeywell controllers. Fluor Daniel actually called me up to go down and look at what they could do, and we were back and forth for a few months, and eventually at the end of the day, well, there wasn't anything they could do. So the systems aren't compatible, so I told them the best bet is to just kind of ride out the contract and get out of Dodge while they can, and they were kind of at the mercy of environmental control systems, and they did get out of Dodge, and now Sodexo has it. Unfortunately, the system's sitting there running, and now Sodexo is in there, as I was outsourced in 2009. But at that point, we really had the system running like a top, like a symphony orchestra running, and you could actually play the system like a musical instrument as long as you knew all the aspects of all the mechanical systems in the building and how they interconnected. It was really some nice thing, a real custom job. Unfortunately, the guys upstairs, they think, oh, we'll just get somebody else. Well, that's not happening. It's just, you don't get guys walking off the street and just take over stuff like this. So it's just been sitting there running. But why don't we take a look at some of the controllers that we have on the system here in my house. Okay, this is my Windows MicroView. It's an Apex with one trunk line. All the DDC programming in this MicroView controls the 3 tuxes in the cellar. The trunk line goes out the back of this unit and it goes down the wall to the cellar. The cable you see coming out the bottom goes to the desktop. It's much easier to look at all the points in the system on the desktop. You could actually put a whole pile of points on that little LCD screen. This thing is powered by 24 volts AC. Okay, this is tux number 1, and this is for the outdoor jacuzzi. You can see it's fairly loaded up. It's a 653, and it controls 2 1.5 horsepower pumps. There's the filter pump that's low speed, high speed, and then there's a jet pump, which is a straight 1.5 horsepower. There's the 2 pumps. The inner one by the wall is the filter pump that is a low speed, high speed, and the one closest is a jet pump. Both are 1.5 horsepower. On low speed, the filter pump is 1/6 horsepower. The jacuzzi is heated off the boiler and has a 75 square foot diatomaceous earth filter. I cross-connected the discharge piping from both pumps to facilitate an automatic bumping process that I programmed into the system. This is the jacuzzi control panel. You have a micro set on the front, and that little red button is the heat push button. It's paralleled outdoor air actuated button, which is that little diaphragm airflow switch right there. A momentary press of that button will give you 45 minutes of heat despite set point, even if it's up to temperature. The microset can read several things. You can read the loop temperature. The pump's not running now. It has to actually run and draw the water from the tub to sample it. I get outside air. It's 39 degrees right now. And basically 91 is the set point, which is on a sliding scale depending on outdoor air temperature. Originally I had the 653 mounted inside the panel here, but there's too much electromagnetic interference when those contactors slam in and out and jumbled up the programming, so I had to move it to the outside. You have two main 2-pole contactors, and those are for each pump, one for each pump. And then you have that single pole contactor that switches between high and low speed on the filter pump. Now I can bring the heat on by pushing this button, and you'll see the filter pump will come on in low speed and then jump to high speed because it's calling for heat. And you can see over in the bottom right there, that's the heat relay, and you heard the boiler pull in. Now when I push the button again, I can turn the heat off. You see the heat drop out. The boiler dropped out. But what's going to happen is there's a 45-second run out to make sure all the heat is out of the heat exchanger. When this pump shuts off, the jet pump will come on for 4 seconds and shoot the water backwards through the DE filter, bumping the DE. And then that will shut down and it'll be ready to go next time I go out and sit in the tub. This maximizes the DE life. Here we go. 4 seconds. Perfect. The auto bump feature maximizes the life of the DE and the filter, and you get maximum flow that way. Okay, this is Tux number 2. It's a 16160. It's basically a stupid Tux. It basically doesn't have any programming in it like the 653 over there on the jacuzzi. The 653 has all the DDC for the jacuzzi programmed into it so it can stand alone. And that way, if you lose communication with the micro view upstairs, it'll still run. The 16160 is dead in the water without the micro view. All the programming for this is in the micro view upstairs. And this basically controls all the boiler functions for the heat and the cooling, also the AC. This is the wood coal fired setup that I've got, the wood fired boiler. You can see we're running coal today. It's in the occupied mode because you can see over here the little LED on the rib that pulls in that circulator for the boiler, and when it does that, it tells that Tux 16160 I'm good to go, and all the zones in the house are in the occupied mode. And the Weil McLean 5-section boiler is locked out right there. See that rib light on? So the oil burner will not run at this point. It's totally running on the wood and the coal. The 16160 also controls the domestic hot water circulators. I have no shortage of circulators here. This box that's mounted here on the pipe, you can have a temperature located right at that spot, and also that's where the connection is made to the well sensor that's in the top of the boiler, back in the back there. I don't know if you can see it. Right there. But that box also has a switch in it to silence the alarm in case the alarm goes off, the boiler fails. So that's basically Tux 2 right there. Okay, here we have Tux 3, and this is for the family room. You can see right now that DOs 1, 3, and 4 are on. DO 1 is the heating call for the circulator to run. 3 and 4 are for low speed and high speed on the fan coil that's running upstairs. I've built that in so that it can be staged. As the closer it gets to set point, it drops to low speed and then drops off as it's like a half a degree below set point. The cooling relay is the other rib on the right hand side of the box up there, but we're not in the cooling mode right now. When the wood fire gets down to 150 degrees, that zone will drop off automatically. Let's go look at the micro set for this. Okay, this is the micro set for the family room. We're set at 73. But with this, you can see what the room temperature is. It's 70 degrees right here. And it'll go away. And it's 69 degrees at a bead sensor that I have in the cabinet under the counter. We can also look at our outside air temp here, 34 now. And if that says 1, it's in the occupied mode because the wood boiler is running. When it's not running, it'll say 0. And when it says 0, we can punch in a number of hours to go into the occupied mode manually right there. Up to 16 I have set. This is the fan coil unit that I was talking about before, where the two relays for low speed and high speed are located in this unit. Okay, we're back up at the desktop, and I have only one screen now. I used to have 3 screens, but my son formatted the C drive on this desktop, and that was the end of that. Everything got lost. I've been putting the pieces back together ever since. I can give you a rundown on how this thing works. All of our set points and temperatures and digital indicators are on the screen that are critical at this point. You can see first we have outside air temp, it's 40.3. Outside air heat enable is set for 60, so the heat won't ever come on unless it's below 60 degrees. And we have the outside air AC enable. The AC won't come on unless it's above 64. That way there we're not heating and cooling at the same time. I took control of domestic hot water, and it's a 147 right now. Set point's 138. It runs over because I sampled domestic hot water for 5 minutes every 25 minutes. And you can see the hot water circ is on right now. It's sampling. The boiler's not calling. After a few minutes in the sampling mode, if it needs, the boiler will come on. But there's an on delay of 1 minute. There's our boiler alarm set point. If the boiler falls below 75 degrees, that little horn downstairs will go off and can be canceled by that button on the front of the boiler. If it gets down to 75 degrees, that's because you had a flame failure. I had to rewrite the boiler program, and this is the set point. It takes a little while for the system to pick up what the temperature actually is. So I have it set kind of low. Current set point at 172. Generally, the boiler will be over 180 degrees by the time it shuts off. This column here just tell you what the wood boiler temperature is right now, 150. The oil burner is at 148. Erica's room temp is 64. It's manually off. Erica's off. Erica's enable set point is when the wood boiler gets to 199 degrees, then it'll go into the occupied mode with a dead band of 10, and then it will drop out. Master bedroom, same thing, 15 degrees. 64 in the master bedroom. Master bedroom unoccupied set point, 64. The family room bead temp is 67. Erica's unoccupied set points. I just added these points randomly because I discovered I didn't have them. There's the unoccupied set point for the family room because it dropped below 67 degrees. There's a dead band of 1 degree there. And at 72 is the set point on the micro set. The way this works is When that wood boiler temperature is running and it gets up to 190 degrees, boom, it puts the zones into occupied mode. The family room especially. The other rooms, it would have to go to 199. And basically, there's our set point. I can change that. Say if I want the wood boiler to jump into the occupied mode, you know, I can set it here. 190 is working good for me these days. You can hear the fan coil shut off because it's over 67 degrees. The wood boiler deadband is 40 degrees, so as it's cooling down, running out of coal or wood, whatever, and the temperature gets down to 190 minus 40 or 150 degrees, this Circ's all shut off and everything goes into the unoccupied mode. Here's our outside air oil enable. It's set for 30 degrees. Below 30 degrees, the oil burner will run in tandem with the wood boiler. Above 30 degrees, it's locked out. Right now it is above 30 degrees, so you see it's locked out. So it's going to run on the wood stove. But the wood stove's not running, so the boiler will maintain the temperature. I have an on delay for the family room of 2 minutes. It's an anti-recycle timer. If the power fails in cooling mode, you don't want to slam that compressor on and off on the condensing unit outside. And I have an off delay set for 10 minutes. Nothing really changes all that fast. The thermal mass of that family room is astronomical. That's why I have to let the oil burner run with the wood boiler, because sometimes you just need that 350,000 BTUs. There's the upper limit and lower limit for that micro set downstairs. I have the family room set for unoccupied all the time. There's the hours that you could punch up on the micro set, and it's off right now. Average temp between the bead and the space sensor on the micro set is 67.6. And I believe I use that as a control point. I really don't know. I lost track of everything. Okay, we have a bunch of stuff for the jacuzzi now. Right now tub temp is 84, but that's the loop that's in the basement. The pump comes on, it'll sample that and draw the water from the tub, which is really probably around 92, 93 degrees right now. The heat status is whether it's heating or not. That heat button is that button I pushed on the panel downstairs, also one outside. You push that button, you get 45 minutes of heat and it goes off. That's in case you forget about it. Bump. Now it bumps every time the pump shuts off, as you saw, but at the same time, if you're sitting in a tub, after a half hour, it'll bump. That on button on that micro set I set for 0.2 minutes. Heat delay is 1 minute. I built this little program here. This is what's so good about this Alerton system. The flexibility is just unbelievable. I can hit this pump one shot and this will turn on the filter pump. But because it's a momentary contact, I had to build a little program in the sequences so that when I click this to go on, you heard the pump come on, but that one shot will cycle off automatically. See? Now the pump will run in 45 seconds, time out, and bump. I have this jets on off here. I can actually turn the jets on from here, but if I turn it on here, I have to turn it off because it's a latching point. I just never got around to making it a momentary. Here's our nice little option that we have. The wood boiler Circ, 20 minutes, I push that button on the front. I can set it for whatever. Half hour, I might do that because 20 isn't cutting it. You heard that bump. So the pump is off now. The wood Circ override, that's when I'm starting it up ice cold and I want to heat up the wood boiler from the oil burner. Push that little button and hold it for 4 seconds down there and it will start the wood circulator and run for now a half hour. Now this 205 set point you see right there, I didn't get around to really plopping a lot of descriptors on the screen, but I know what that is. Say you have the coal-fired boiler going, full bore, and it starts to get really hot in the house, and it shuts all the zones off. Well, you got a problem, because now that coal, you can't stop it. So at 205 degrees, it automatically turns on the jacuzzi and dumps all the waste heat into the jacuzzi like a cooling tower. 210 is if the jacuzzi is drained, all the house zones come on, all those normally open valves will spring open, all the pumps come on and dump the waste heat that way. This boiler rib status tells us if the boiler is running or not. Right now it's a no-go. Cellar set point, it's a little reset schedule. I wanted to get rid of it, but just haven't got around to it. Okay, here's our tub set point. It's on a reset schedule. Generally, I'll change this. Is it summertime? I really want to have that thing running at 89 degrees to cool off. But right now, the reset schedule runs that when it's 65 degrees outside, the set point is 90. When it's 30 degrees outside, it's 92. I can change that, basically, when it's like 30 degrees and it gets down to 20, 0, 5 degrees around there, you really want to have that at 94. Now you can see that here's the set. See it changed? That's how long it takes to change. Three seconds, and I'll explain why that is. Well, what I had to do was go back to my winter interval. I had this program before, but I'd put it back in. Every 90 minutes, the filter pump comes on and samples if the jacuzzi needs heat. When it's 5 degrees out, it pays to add a little heat every hour and a half. It's much easier than trying to heat up that monster 8 yards of concrete and 800 gallons of water from like 84 degrees all the way to 92, 3. So the best way to do it is just sample it every hour and a half, and the water sample is 120 seconds. The heat on delay is 1 minute, 60 seconds. So as soon as the 60 seconds is going by, and that thing needs heat, it'll come on and stay on until it gets up to 92. And generally, it's not that long. Believe it or not, all winter long. There's our pump run out of 45 seconds to get the heat out of the heat exchanger, and then the bump, 4 seconds. So, and this is our pump status. It's off right now. Basically, that's our screen. This is the DDC that's located in the micro view, or Apex. So we'll go to Edit DDC, and you can see now we'll have a sequence. They start from 0 and go to 9,999. And we can advance this sequence number 1, 3, 50. We like to leave room in there in case you want to add something later on. This sequence 120 is important. As you see, it's a temperature convert. All you have to do is know where your outside air input is terminated on what tux, and it's terminated on tux 1, 2, analog input 0, 3. So we're going to convert that input to degrees Fahrenheit and send it to IBEX 12. It's good to use IBEX points. They plop them on the screen and you can work with them. So we can even look at this. This is real handy in Apex DDC. You can actually read the values. You see that 71.6 there. Those are 3,000 ohm thermistors. The input for Alerton is. Honeywell's 10,000. 71.6, it's like a percentage out of 0 to 3,000. Converts to a temperature of 40 degrees. which is what it is. So we can see, here's a good example. IBEX 12, which is outside air temp. We take IBEX 12 and we can shoot it to Tux 11 AIO2. So now the jacuzzi is Tux 11. We'll know what the outside air temperature is and can run its little reset schedule. We'll use IBEX 12 quite a few times in this program. That's why it's good to have it as an IBEX point. There it is. There it is again. So the Apex scans through all the sequences I've programmed in here. Generally what we do is go to 5,000 and at 49.99 and put end of normal sequence device. That's because in the normal sequences you can use subroutine callers, and I still have in here, starting at 5200, a program that I built up for Al Hennessy at Unilever that generally they have two 210-ton train rotary screw machine chillers there for the data center. And the way it works is when you have one chiller running, you got one chill water pump running. But sometimes Al wants to run two chillers at the same time. It's like 420 tons of cooling. So automated building systems neglected to give them the feature to turn a second chill water pump on to run along with that the next chiller. So this is what this system does. All he has to do is hit a 2 chiller run button and boom, will automatically switch to both chillers on and 2 chill water pumps. So this sequence goes from 5200 all the way to a lot of stuff in here. It was not easy making that happen, I can tell you right now. 5518 from 5200. We can go back to 0. The way this Apex works is it scans through every single one of these things, goes to that subroutine caller, inputs the inputs to the subroutine, gets the outputs back, and goes all the way through the whole thing to the end, which is 9,999, all in the time of 3 seconds. You remember how long it took to change that set point? 3 seconds. I think we're looking at alien technology here they got from Roswell crash. That's all I can think of every time I do this stuff. It's insane. But 3 seconds is an eternity when you're traveling at the speed of light, so we can get out of here. Now that's Apex DDC. We have Tux DDC, and we have 2 Tuxes on the system, and we have to configure for it. This is Tux 1, so okay, yeah, we'll do that. We'll go to the function menu. What do we want to do? Let's read the DDC from the Tux. It takes a little while to get all of that out of there and bring it up here. Done. Okay, let's take a look at what we got in there. Starting at sequence 0. That's the jacuzzi. That's loaded into a 653. We configure and we can look at Tux 1.3, the family room job. We can load that DDC from that Tux. Done. So we have this. And that's it. There's a fair amount of stuff in the Tuxes, and they have to coordinate their DDC with the DDC in the Apex. That's why the 3 second delay. The great thing about having DDC and the tuxes, like the APLC and 653, is they can stand alone. In the event of a power failure, you'll see this little green LED that normally blinks to tell you you have communication. This will become solid, and it takes the program and burns it to an EEPROM in here as the power dies. Then when power is restored, it automatically reloads the program to itself and takes off running. It's unbelievable. Bulletproof. I have the same 3 tuxes since day one here. Never had to replace them. And how many power failures? It's unbelievable. There's really a lot more stuff you can do. You can do even a user audit here. Anybody logs into this thing, records date and time, and you can see every time I log in, and it even says what I did. Problem with the system, you got to keep an eye on it and just make sure everything's running. Take a look at it every once in a while. Most building managers have no idea what's going on with this thing, and it just sits there and runs, and everything is like kind of half working, and nobody knows why they're freezing or sweating. Basically, that's it for the house systems. Only has 3 tuxes on it. Well, that just about wraps up the Alerton tour for today. Few people understand these types of control systems. We operate in the background, under the radar, totally out of sight. Whenever I went on the job site, job super was usually a carpenter, would ask me, what are you going to do here today? And I'd say, I'm the control guy. And he'd say, okay, and I'd never see the guy again. But I had to interface with all the electricians, plumbers, and mechanical contractors, carpenters, so I actually knew the job inside and out better than the job super. And so I always kind of went and tipped him off potential problems that were upcoming, things that needed to be done that he wasn't aware of. So he kind of liked to have me around. Thing is, we always did whatever it took to get the job done. People were in the way. People are an impediment to progress. You know, there was another guy like me, Stanton L. Potter. That guy worked 14 hours a day, Sundays too, as an example of doing whatever it took to get the job done. Stan went to a school on a Sunday and it was all locked up, so put his ladder up, climbed up on top of the gym, and the rooftop fans weren't installed yet, so he just pulled the plywood off and he lowered himself down the 35 feet to the gym floor with a 12-3 extension cord, and opened the doors, brought his stuff in, worked all day, did his job, and locked up and left. Nobody ever knew he was there. It was just easier to work when nobody was there, nobody in the way bothering you. And but he wasn't a diplomat either. You know, the time I was with him, I helped him on occasion. And job super says, "Why don't you ever talk to me?" And Stan just looked at him and said, "You are a carpenter." Like the guy was a retard. Well, boy, Stan needed some lessons in diplomacy. Dan Beaupre was the best programmer that Automated Building Systems had, but his work was flawless. Oh, perfect. The thing is, he was so obnoxious and insulting to everybody all the time, and nobody could say a word to him because he was perfect, you know. So one time we were up in Massachusetts, and professional engineer, PE, he was really ripping because Dan just programmed the job the way he wanted to, and the PE was really mad, and Dan told the PE that it was stupid the way he wanted to do it. Well, you can't tell a PE that it's stupid, you know. And the guy, he shouted at him, "I'm a PE." And Dan said, "What's that, a premature ejaculator?" Oh, I had to break that one up. Dan, His favorite saying was, "There's nothing dumber than a plumber." Boy, those guys were an adventure. But I gotta say, I worked on some of the most interesting job sites that exist on the face of this planet. Really interesting work. But, I think that's what's wrong with this whole entire world these days is everything is run by people who have no practical experience with anything at all, like the PE, I mean, he got his degree, he designs up this stuff that isn't even going to work, it's stupid, and, Dan just said, well, heck with him, we'll do it our way. And the guy gets mad because, he's a PE, professional engineers, they design something wrong, and it doesn't work, you have to pay them to fix it again. How does that work? That is a good deal. My stuff doesn't work, I have to go fix it for nothing. It's frustrating. But, the other thing is quality control. We have no quality control anymore. They just manufacture stuff and ship it. They don't even test it, especially now in China. Boy, half the stuff you get is no good right out of the box. Well, I was at Unilever for 10 years, and boy, it was some nice thing. I mean, Al and AJ, they're the best mechanics I've ever seen in my life. And, Unilever, they didn't care. They just outsource them. They would just get somebody else. Well, that didn't happen, and the thing's been crumbling ever since. So the bottom line is, I think I enjoy carpenter work the most, because at the end of the day, it looks nice, and everybody who sees it, oh yeah, that looks nice, and that's all that counts. If it looks nice, nobody understands if it works, because people don't understand the mechanical aspect, so it goes unappreciated. But I kind of like to have it look nice and work right. But nobody ever wants to pay for that, and that is a problem. So that's the way it is. Thank you for your time.